Well, hello students, welcome back to mathematics class with me, Mr. Alfie. In this video, we're going to learn about operation of matrices. Turns out, we can treat matrices like regular number. We can operate them like add them, subtract them, multiply them, but we can't just divide them. That's the beauty of matrices. In this particular video, we're going to learn about addition and subtraction of matrices. Now let's talk about addition of matrices. If A and B are two matrices of the same order, the sum A plus B is the matrix obtained by adding the corresponding elements in A and B. Let's elements of matrix A are A, B, C, D, and elements of matrix B are P, Q, R, S. A is the element of matrix A in the first row and the first column. A is corresponding with B because B is the elements of matrix B in the first row and the first column. So we add A plus B in order to find matrix A plus B, and then we put the sum of those numbers in the first row and the first column of matrix A plus B. And then we do the same with B. B is the element of A that has corresponding element with Q, where Q is the element of B. So we put B plus Q in here, and then C corresponding with R and D is corresponding with S. So C plus R and D plus S. This is matrix A plus B. For example, for addition, it's quite simple. We just need to add the corresponding element to another element in other matrix, like 1 plus 5, 4 plus 6, 2 plus 8, and 5 plus 8. Another example. It is given that matrix A, B, C, and the elements are listed here. Evaluate A plus B plus C. How to evaluate three matrices? If the addition of three matrices, we simply just add those numbers at once. So A plus B plus C, you just add all the matrices and then add all the corresponding element. Like 3 is corresponding with 2 and also corresponding with 6. So we add those three numbers together, and so on with 5, -1 and 2, and the other elements. So A plus B plus C, we simply just add the corresponding element. And remember, each matrix A, B, and C has the same order. All matrix has the order 3 by 2 because there are 3 rows and 2 columns. So we add all those numbers together and we'll find that matrix A plus B plus C equal to this matrix. It's quite simple. And the sum of matrix A plus B plus C still the matrix with order 3 by 2. It has to be the same order. How about the subtraction of matrices? If A and B are two matrices of the same order, remember the same order, then the matrix representing the difference A minus B is obtained by subtracting the elements in B from the corresponding element in E. Or the other way, we just need to subtract the element of A with the element of B. So the elements of matrix A are A, B, C, D, and the elements of matrix B are P, Q, R, S. Remember, subtracted the elements of A with the corresponding element in B. So A is corresponding element with B. So A minus B. And B is corresponding element with Q. So B minus Q. And so on with these two other elements C and R and D and S. For example, there are two matrices. The first rule is they have to be in the same size. So 2 by 2 and 2 by 2. Remember, and then you operate with subtraction with corresponding element. So 1 minus 2 equal to -1, 4 minus 3 equal to 1, 2 minus 1 equal to 1, and 5 minus 3 equal to 2. Another example. In a school bookshop, the stocks of mathematics geography books for secondary 1, 2, 3, and 4 at the beginning of the certain month are represented by the matrix T. So the first row of matrix T represents the number of mathematics book, and the second rows represent the number of geography book. And the first column represents the total book of mathematics and geography in a secondary 1, and the second column for secondary 2, secondary 3, and secondary 4. Then, during that month, none of these books were reordered, and the numbers of these books sold are represented by this matrix, matrix Y. Matrix Y. The first row of matrix Y is representative of the total numbers of mathematics books that sold in that month, and the second row is representative of the total of geography books that sold in that month. The first column represents the total books of mathematics and geography sold in secondary 1, the second column with secondary 2, secondary 3, and secondary 4. Now, find T minus Y. We know that this is the matrix T and then this is the matrix Y. We simply just need to subtract it. The element of matrix T with corresponding element in matrix Y. So we will get the matrix T minus Y equal to this matrix. And remember, matrix T has order 2 by 4 and matrix Y also has the order 2 by 4, 2 rows and 4 columns. And the matrix T minus Y, it has to be 2 rows and 4 columns. That's the order. And then interpret the result in A. What this matrix represents? The matrix T minus 1 represents the remaining stocks of the 2 books for the 4 levels at the end of the month, because T is the total number at the beginning of the month, and matrix Y is the matrix represent the sold book. So matrix T and minus Y is the remaining book in that month.